Hi, welcome to the screencast for Option E or Topic 16 from your book on environmental chemistry. I'm going to start out by going over sections E1 and E2. E1 starts out talking about air pollution in general terms, and then E2 looks more specifically at the idea of acid rain. So the effects of human activity on our environment finally is being acknowledged, I think, pretty much by every country. And one of the big issues with pollution is whether it's in the air or the water is it doesn't stay within the boundaries of the country that creates it. So there's a lot of politics involved, as to who's creating the pollution and where the pollution is ending up. Air, water, and soil are the three big ones that we are concerned with polluting, and all three are being polluted. And all three have effects on the others. So environmental chemistry is definitely a growing field. It's not necessarily a well-paying or respected field, although I would say it's becoming much more so than it was, even 10 years ago. So looking at air pollution first, a pollutant, whether it's in the air or soil or water, is a substance which has a harmful effect on the environment and is present at levels greater than its natural levels due to human activity. So many of these pollutants exist naturally. The issue is that we've raised them to unnatural levels. Mother Nature or Mother Earth is able to take care of the pollutants it produces naturally through, volcanoes or whatever the activity is. But it's when we put stress on that system that the natural systems can't keep up. So pollutants, the effects depend on their concentration and then as well as their toxicity. The other big thing is the average length of time they remain in the atmosphere. Some have a very short atmospheric lifetime, others have a very long one. So those are the big three that are considered when we talk about pollutants. With air pollutants especially, but with any pollutant, you could talk about primary and secondary pollutants. Primary pollutants are ones that are emitted directly into the atmosphere. So like CO2 and CO both come from cars, occasionally NO. SO2 is a big one from burning coal plants. Those are all primary pollutants, and sometimes even more dangerous are the secondary pollutants, and that's what these things become when they combine with other things in the atmosphere. For example, CO2 will naturally combine with water to make carbonic acid, H2CO3. SO2 will combine to either make SO3 or it can combine with water and make H2SO3. It can also make H2SO4. So we end up with sulfuric and nitric and carbonic acid all being produced very quickly from these primary pollutants. So carbon monoxide is one of the big pollutants. So is carbon dioxide, but the book starts with carbon monoxide. It's toxic because it binds to hemoglobin and then oxygen can't. So it's more reactive. It's going to have preference in binding with the hemoglobin over just oxygen. It's anthropogenic, and anthropogenic is a word you should be familiar with. It just means it's human-made. Sources of CO are burning fossil fuels and forest fires with limited oxygen. So combustion's incomplete. So CO is always the result of incomplete combustion. It's often a local pollutant, meaning it gets heavy in cities or where there's heavy traffic. You'll have a buildup of CO during rush hour. There are a few natural sources, oxidation of methane, but it's very minor. Okay, that's just forms from the decomposition of, leaves or whatever breaking down in the soil. So it's mainly us who are creating the CO levels. Methods of controlling them, the biggest thing is internal combustion engines, which is pretty much any engine you could think of, whether it's a lawnmower, a jet ski, or your car. Three big ways to control it. You should be aware there's three different ways to control it. There's what are called lean burn engines, just making sure there's enough oxygen. Catalytic converters, which in this country every car is required to have a catalytic converter, or a thermal exhaust reactor, and they all work by converting the CO to CO2 if it's produced, although the lean burn engine just prevents the CO from being produced. Catalytic converter, if you're only going to remember one, I'd remember catalytic converter because it also converts NO, so it takes care of two pollutants with one process. NOx, that just refers to nitrogen oxides. It could be NO, NO2, NO3. It just refers to the various nitrogen oxides. Typically, nitrogen and oxygen don't react unless the temperature is really high because of nitrogen's triple bond, and also oxygen has a double bond, which is a good thing when you think that our atmosphere is made up of 80% nitrogen and 20% oxygen. And we want a stable atmosphere. We want plenty of oxygen for breathing and other processes. So main nitrogen oxides that create havoc with our environment are NO, NO2, and N2O. And they can all end up forming HNO3, which is a strong acid, or they can all react with hydrocarbons and form smog. So NO2 is the most toxic, meaning it causes the most damage. It irritates eyes and lungs. And all NO2 and 80% of NO are produced naturally from bacteria breaking down. So that's mostly a natural process. The anthropogenic sources of nitrous oxides are burning fossil fuels again, and burning coal or oil for power plants. By far the biggest source is vehicles. So both carbon monoxide and nitrogen oxides are primarily a result of vehicles. So the methods of control, again, lean burn engines, keeping the air to fuel ratio high. The catalytic converter, the nice thing about the catalytic converter is it takes both carbon monoxide and nitrogen monoxide, and you end up getting carbon dioxide and nitrogen gas. And then the other one is this exhaust gas recirculation, and that's by lowering the temperature, so it just lowers the amount of NO produced. So two of these, both the lean burn engine and the EGR, just reduce the amount of NO produced, whereas the catalytic converter actually converts it into another product, a less harmful product. Sulfur oxides then, these are primarily a result of coal, natural sources, volcanoes, and rotting vegetables. SO2 is the primary pollutant, but it easily becomes SO3 in the atmosphere, and either one of these can easily combine with water to form sulfurous or sulfuric acid. Both strong acids, well actually just sulfuric acid is strong acid, but both acids. So again, the anthropogenic sources are burning fossil fuels, smelting plants, which are oxidizing sulfide ores to get the metal out to form metal oxides, and sulfuric acid plants. And sulfuric acid is a big business because sulfuric acid is used in many, many industries. So the basic reaction, let me scroll back down there again. Basic reaction is that SO2 just combines with O2 to form SO3, and then when it dissolves in H2O, it just is a synthesis reaction to combine and form H2SO4. So what are the methods of control? Most methods of control are done after the burning is done. Sulfur can be removed before you burn coal, but it requires crushing and washing the coal. Currently, most of ours is done after. So alkaline scrubbing is using calcium oxide or calcium carbonate, and it's sprayed with the exhaust gas where the SO2 is, and that'll combine to form calcium sulfide. That's a common one. Fluidized combustion mixes powdered limestone with the coal. So it mixes with the carbon monoxide in there as the coal is burned. And the other one is just to use low sulfur content coal. But those are the three main methods used after, if you don't crush and wash it before. And again, in this country, we still tend to look at the after methods. Another pollutant, primary pollutant, is particulates. This is just, small solid chunks of carbon or dust, even droplets of mist or fog, water, just large enough to see. These all disrupt the atmosphere, cause smog, cause pollution. So natural sources are sulfur from volcanoes and dust from the breakup of solids, or this time of year especially pollen in the air, pollen and spores. But the man-made sources are soot from burning coal, asbestos, which hopefully there's not as much anymore, and something called fly ash, which is just ash that is very small and ends up in the air. So it's removed naturally by gravity just settling it out over time, but it can be removed from the emissions, at the source as it's being produced, either using filtration, something called centrifugal separation, where they spin it to get it to settle out, put it through settling tanks, scrubbing, and then electrostatic precipitation is where they use positive and negative charges to try and pull out or attract the particulates. E2 then, acid deposition. This is all about acid rain. Deposition is just like precipitation. It deposits it. So it could be, it's just when precipitation has higher than usual acid content. We call it acid deposition. It can also be done dry with just acidic gases or particles settling out. It's caused by the sulfur and nitrogen oxides. It includes acid rain, but again, it can also just be deposited dry, or you could have acid snow or acid fog. So acid rain is kind of a misnomer. It's not the only way that our pH gets disrupted. And one big thing that IB will expect you to know is that rainwater is naturally acidic. It's around a pH of 5.6, which isn't really highly acidic. And that's because CO2 and water naturally combine to form H2CO3. It's all the extra acid formed by the nitrous and sulfur oxides that drop that pH below 5.6, and then we consider it acid rain. So the basic reactions, the secondary pollutants form when SO2 combines to form H2SO3, or SO3 combines to form H2SO4, or NO2 combines to form HNO3. And these are all just simple synthesis reactions, so really not too tough to keep in mind. The effects of acid rain, the big effect is on marble and limestone, anything that contains calcium carbonate, which both marble and limestone do, because calcium carbonate is far more reactive with sulfide ion, so it'll become calcium sulfate, which means that your marble or limestone will wash away, that it'll have a corrosive effect on it. The SO2 and acid rain also corrode metals. They damage plant life by leaching out important nutrients. It also releases aluminum from rocks, which can damage roots, and the SO2 can block the stomata on plants and prevent photosynthesis. So those are some of the negative effects of acid rain. As far as aquatic life, if the pH of a lake drops to 4, it becomes fishless or dead, but before then you start seeing problems. It also, the nitrate promotes excessive plant growth, so you'll see a process called eutrophication start, where more and more algae grows, which depletes the oxygen, which kills other things off. And then there's more dead material, which promotes more algae growth. You just get into this cycle where eventually the whole lake becomes greener and greener until everything's dead. The main effects on human is respiratory irritation, so that's why one reason why we think there's so many more people with asthma these days. Also leads to bronchitis or emphysema, eye irritation, and it also releases poisonous metals into our water, which can have longer term effects. So how do we control acid rain? The big thing is controlling the emissions that lead to it. So again, the NO is controlled with catalytic converters, lean burn engines, the ERG engine or EGR engine, whichever it was. And then the sulfur is all about controlling the sulfur content in coal, either by crushing and washing it before or controlling it during the emissions using scrubbers or some other method. We also can use alternative energy sources. We should be looking at that anyway for fossil fuels. And to minimize the damage done to lime, you need to neutralize the acid into calcium sulfate and water before it hits those statues and such like.